Hey everybody, I'm Ben, and in this screencast I'm going to show you how quick and easy it can be to build your own GraphQL server. Now, why would you want to build your own GraphQL server, I hear you ask? Well, there are hosted services out there already like Prisma and even AWS AppSync, but if you've got the sort of clients that Shine does, i.e. big enterprises, it's probably a bit too soon for them to be using services like that. The intricacies of their infrastructure and even their business domain make it likely that if they're going to want to use GraphQL, they're probably going to write a GraphQL server themselves. So I think it's definitely a topic worth understanding. To demonstrate, I'm going to use a to-do list, but I've added a little bit of a twist to this one. As well as being able to add new to-do items to the list, each to-do item can also have subtasks added to it. And I've kind of gone to the effort of adding this because what it means is that we can now have a schema for our application. Specifically, we've got a to-do item, and a to-do item can have many subtasks. And because we have a schema, we can describe this using a GraphQL schema. So here we've got a schema describing the type to do. The to do has three fields: ID, description, and subtasks. The subtasks field is an array of subtask objects. The type subtask contains two fields, an ID and a description. And all of the exclamation marks just mean that things are not nullable. Similarly, we can describe the queries that are possible for this schema. We're going to use the convention of having a type called query that represents the queries for the root object. In this case, it's got two fields, to-dos, which will get an array of all available to-do objects, and also a to-do field that takes an argument that is an ID and returns the single to-do that has that ID. Now, if you're new to GraphQL schemas, it's worth keeping in mind that the query type is just like any other type, the only exception being that by convention, if a request comes into your GraphQL server that has an operation type of query, that's with a lowercase q, then the server knows to map it to the type query with a capital Q in your GraphQL schema. But other than that, it's pretty much a type just like any other. The schema also contains a mutation type. This is what we use for creating and deleting items. Because mutations are kind of like a query with a side effect, we name them more using using verbs rather than nouns. So you see we've got create to do, delete to do, and so on here. And similarly, the mutation type is just like any other type, the only exception being that if a request comes in with a operation type of mutation, it's with a lowercase m, then the server knows to automatically look for the fields in the mutation with a capital M type in the schema. Now let's assume we've already got the client written and also that the database is already set up, and we've got some logic just for doing object relational mappings into the database. In this case, I've just used Sequelize to set up the database for me and define objects for creating and manipulating subtasks and the relationships between them. I'm going to use Apollo server to write this GraphQL server. And that's as simple as using yarn or npm to just add it to your project. I'm also adding Facebook's GraphQL package, which is a peer dependency of Apollo server, although we won't be using it directly. So on the right here, I've got the to-do list client running. And on the left, I've got sort of the beginnings of a server, but the server's not running, so the client is currently experiencing errors. There's a few things in this server that I just want to point out before we get started. I'm getting the Apollo server and GQL objects out of the Apollo server package. I'm also doing a little bit of housekeeping to load the schema file from the file system into a string, and then I'm converting it into a typedefs object using the GQL helper. Now the actual meat of the server is where we instantiate a new Apollo server. And every Apollo server takes at least two things: a set of typedefs and a set of resolvers. and you'll see that I have brought in the resolvers up here, and I'll get back to exactly what those are in a second. To actually start the server, we call listen on it. I'll just log whenever the server starts. And now I can start my server here. I'm just running it using Node, running the JS file using Node, although I am using NodeMon, so it'll automatically pick up any changes that I make. Let's wait for the server to start. And then I'd like to say that it's going to work, but the server still knows nothing about the data sources that are available to us, and this is where resolvers come in. So resolvers, or a resolver map, maps a set of GraphQL types and fields to what are called resolver functions, which are actually what is used to look up data for that particular field. So in this case, I've already got a top level object in here that maps to the query type, and we know that the query type had a couple of fields on it, for example to-dos. So I'm going to write a function that gets the data for all of the to-dos. Having done that, I can now restart my server and the data loads for my to-dos, which is fantastic. Now I'd also like to be able to click through to a particular to-do, but that's not implemented yet either on the server. And if you remember, there's a query. This is what the query looks like that gets a to-do. It's got looks up the field to-do with an ID. So I'm going to implement a resolver function for that. Now resolver functions get a couple of different arguments. The first is the parent object. We're going to ignore that in this case because it's a root level query. The second argument is the arguments that were provided to the field, and that's args. We'll call that args, and that is one that we're interested in because we want to look up a particular to-do by the ID that has been provided to us. ID. Now I can try that again now, and I'd love it if it worked, but there still is one problem, and that is that if we look at our get to do query, it's also getting subtasks for each to do item, and at the moment the server's got no way to know how to get subtasks. So this is where we can actually introduce an entry into our resolver map for the task type, or the to do type, I'm sorry, and specifically the subtasks field on the to-do type. Now in this case, this is another resolver function just like the other ones. However, because it's working on data returned recursively, it does have a parent object, and that parent object is the to-do item. So we're going to use that now. So having done that, when the GraphQL server received the request, it first ran or loaded the to-do field on the query type, and then when it saw that the query was requesting the subtasks on each to-do item, it called the subtasks resolver function. Similarly, we can do mutations. Again, because the mutation type operates on the root object, we kind of ignore that first argument. However, we are interested in the second one, which is the arguments. When we create a to-do item, we have a description passed to us, so we're going to do. So that resolver will create a to-do and return it. So if I return to the home page of the app and add a new to-do item, it'll be created successfully. And that in a nutshell is how you get started writing your own GraphQL server. You provide a resolver map that at the very least contains resolver functions for your query and mutation types. And then if you've got other types that have fields of their own that refer to sub-objects, and you provide resolvers for those as well. I guess one of the big strengths of GraphQL is that if you consider the query that I ran to get all to-dos, it only really is asking for an ID and a description. So the JavaScript that comes back from the server looks a bit like this. However, if, say, in requesting all to-dos, I also requested that all of the subtasks for each to-do in the list got returned, then the server would automatically resolve those subtasks for me without me having to make any additional changes to it. And that's kind of the beauty of GraphQL in a nutshell. Once you've specified resolver functions for fields, you can write queries that request those fields in whatever way you see fit, and the server will be able to satisfy those requests for you. A few important things to note before we finish up. This is not really just for databases. I've used a database and an ORM just because it was simple to set up, but the real power of GraphQL comes in when you start aggregating data from different sources like RESTful endpoints and so on. Secondly, from a security perspective, you probably wouldn't want to expose a GraphQL API completely unprotected to the broader internet, simply because you don't know what sort of queries are going to be run against it by clients. For example, someone could write a very deeply nested query and overload your server. So to deal with that, what we can do is whitelist queries by creating hashes of the queries and making it that only those queries are permitted to be run in a production environment. During dev, developers can write whatever queries they want, but then when everything's ready to be locked down, you can actually restrict which queries get run. And that ties in a little bit to performance as well, because if you take the hash of a query, a permitted query, and also the hash of the arguments to that query, you can combine them together and effectively they become a cache key, which can then be used with a CDN or something like that to cache results so that resolvers don't necessarily get executed over and over again. Finally, you don't have to write a server in Node. There's libraries for lots of other frameworks like Java and Ruby and so on out there. So that's how quickly and easily it is possible for you to get started writing a GraphQL server for yourself. I encourage you to get out and have a little bit of a play around. In my experience, it's actually easier to write the server-side logic than it is to write the client-side. So it's definitely something that you shouldn't be too intimidated by. That said, it really takes a shift in mindset when you start using GraphQL. You've got to start thinking in terms of the data scheme and not so much endpoints as you maybe once did with REST APIs. Thanks very much for watching.